Lesson 29, solving radical equations. So in lesson 28, we've already been doing this, but now we're going to do some that are much more complicated, that involve a little more algebra savvy skills. So here we go. How are we going to do this? Well, our plan before was to isolate the radical, right? So we need to get that square root of x by itself. So the first thing I'm going to do is I'm going to subtract x from both sides. So I'm going to have 6 minus x equals the square root of x. Okay? And this is where things get different. It gets a little different. Because now I need to square both sides. And don't write this down, but the tendency would be for you to say, okay, if I'm going to square both sides, that would be 6 squared minus x squared, right? Let's just square both sides. But it's not the case. You wind up actually squaring the whole thing. So this is what it actually looks like. This is actually what it looks like when I square both sides. Okay? No, I'm sorry, I said don't write it down. Probably tons of people wrote it down. And then probably tons of people watching the video wrote it down. It's okay. I would have written it down too. So, now we have to FOIL this thing out, right? And that's because 6 minus x squared is the same thing as 6 minus x times 6 minus x. Right? And I'm sorry, I am plumb out of room, so I'm going to go ahead and write this up here. All I'm doing is rewriting the problem, okay? Just rewriting where I'm already at. Okay. So let's go ahead and FOIL. So 6 times 6 is 36. 6 times negative x is negative 6x. And negative x times 6 is negative 6x again. And then negative x times negative x is positive x squared. And that's all equal to x. I'm going to go ahead and combine like terms now. And I'm actually going to write it in standard form. So I'm going to go ahead and put my x squared first. I'm going to have negative 6x minus 6x. That's where I get that negative 12x from. Plus 36 equals x. Now I need to subtract x from both sides. Alright, so now I have a quadratic, so what I need to do is subtract x from both sides. I'm setting it equal to 0. And it turns out that this is factorable, even though it looks nasty because of that 13. It's going to be okay. So I need to think of two numbers. Then if I multiply them, I get positive 36, and if I add them, I get negative 13x. I like 9 and 4. So I got 9 times 4. And then it looks like they're both going to have to be negative, right, in order for them to add to negative 13, right? So negative 9 minus 4 is negative 13. And negative 9 times negative 4 is positive 36. So that means that my possible solutions are x equals 9 and x equals 4. And why do I say possible solutions? Because they're not really solutions until I check them. So I'm going to go ahead and check 9 over here. So 6 equals 9 plus the square root of 9. So what am I saying? I'm saying 6 equals 9 plus 3. That's not good, right? No. So that would mean this one is extraneous. And now we got to check 4. So we have that 6, right? And I'm plugging it into this. I'm plugging it in here into my original equation. 6 equals 9 plus the square root of 4 My bad, sorry, 4. Wow, I just was writing what was above it. Sorry about that. I'll get it. 6 equals 4 plus the square root of 4. That's better, right?
Oh, and then square root of 4 is 2.
Square root of 4 is 2, so that one checks out. So this is our actual only solution. So be careful. If on the test you say that they're both correct, you will not get full credit. You're going to be minus points. So I mean, you could cross this out. You got to show that you've checked it, right? Or you could say that it's extraneous. A bunch of options. Let's do another one. That was fun. Looks like we have 4 to do. And not a lot of room. So I'm going to go ahead and start this one way up here. And I'm going to, just because I'm really running low on room, I'm going to go ahead and subtract 1 from both sides right away. All right, now I don't like that 2 is there, so I'm going to go ahead and divide both sides by 2. And that's going to allow me to isolate my variable. Or isolate the radical is really all I want to do. Okay, I want to get that radical by itself. Well, gosh, now when I square both sides, I end up with 3x minus 1 over 2 squared equals x. That's great. I have to divide both sides by 2 in order to get that 2 to go away from in front of my square root of x. This is probably not going to be pretty. All right, so that's going to be 3x minus 1 over 2 times 3x minus 1 over 2. Darn it, you know, things that I want to I'm going to rewrite this over here. Except for I'm going to go ahead and write that as 3 halves x, or 3x over 2 minus 1 half times 3 halves x, or 3x over 2 minus 1 half. That's better. Ran out of room. That's an x there. All right, there we go. So now we got to FOIL this. It's going to be a little gross, but it's going to be okay. So that one times that one is going to give me 9 over 4x squared, because I've got an x times x. This one times this one is going to give me, remember I'm multiplying both my numerators and my denominator, so that's going to be 3/4 x. This one times this one is also going to give me 3/4 x. And that times that is going to give me, remember, again, multiplying my numerator and my denominator. Negative times a negative is a positive. And 1 times 1 is 1, and 2 times 2 is 4. Equals x. Kind of gross. We're going to combine like terms. So the cool thing is those have the same denominator, so I can call that 6/4 x plus 1/4 equals x. I need to subtract x from both sides now. So, and actually, how about this? instead of writing it as x, before I get done, I see that everything has a common denominator of 4. Actually, let's leave it as x. I just came up with a great idea. Remember how when we were solving rational equations, we could multiply the whole equation by the common denominator and make the fractions go away? Why don't we do that and make our lives easier, right? So check this trick out. I see 4, 4, 4, right? So it should be the case then that if I multiply everything by 4, the 4s will go away. So this is my plan. I'm going to multiply that by 4. A little trick. It's going to make life so much better, right? What that's going to do is make this cancel, so I wind up with 9x squared equals 6x, right? Because the 4s are always going to cancel. Yeah, because if I had 9 times 4 here, they would cancel. You know what I'm saying? Plus 1, and this one is actually going to get the 4, right? It doesn't count 4 as a denominator, or my 4s would cancel. That's much better. I'm happy again. Yeah, I'll subtract 4x from both sides. So we end up with 9x squared minus 10x, no? Plus 1 is equal to nothing, no? It's all equal to nothing, no? Porque it's not even good, no? Alright, well, is it factorable? I'm checking to see, right? I'm multiplying the 9 times the 1. And I'm seeing, are there two numbers that if I multiply them, I get positive 9, but if I add them, I get negative 10? Yes. There are two such numbers. Those numbers are negative 9 and negative 1. So I'm going to get out my X box method. So I did A times C on the top, 9 times 1 is 9, and B on the bottom. And I discovered that indeed, if I multiply negative 9 and negative 1, I get positive 9. And if I add them, I get negative 10. So now I get out my box. I know we did this a while ago, but it's still a handy dandy tool. I put my 9x squared here. I put my 1 there. Okay, so I got the 9x squared from there and the 1 from there. In the box, I'm putting my negative 9, and I'm giving it an x, and I'm putting my negative 1 over here, and it gets a variable as well. Now I find the greatest common factor of my of this column, right, and that's 9x. The greatest common factor of this one is going to be 1. The greatest common factor of this row is going to be x, and the greatest common factor of this row will be just 1, right? And thus it has been factored. Now, because both of these are negative, both of my signs here are going to be negative. So I'll have 9x minus 1 and x minus 1. And it's always good when I'm done factoring to check and see if it's going to work, right? So 9 times negative 1 gives me negative 9. Negative 1 times x gives me negative x. And negative x minus negative 9x is negative 10x. We're good. Just checking it. I'm just foiling it. I'm multiplying in my head to make sure that I do get the same thing, right? That when I multiply this, it brings me back to that, right? So I'm checking to see if I multiply this one times this one, I get negative x, right? And then when I multiply this one times this one, I get negative 9x. And negative x minus 9x gives me the negative 10x. Also, negative 1 times negative 1 gives me positive 1. It's good to go. I just check it to make sure I factored right. It takes 20 seconds at the most, right? Just to make sure that I got it right. So let's find our solutions. The easiest one is that x is 1, right? But then to do this one, we've got to solve 9x minus 1 equals 0. We'll add 1 to both sides to get 9x is equal to 1. So x is going to be equal to 1/9. Yeah, these are quite a bit of work to do. And those are only our possible solutions. They're not solutions until we check them. So we got to go back up to the top. I'm just gonna. All right, let's go back up to the top. So if I plug in 1, 3 times 1 equal to 1 plus 2 times 1. Heck yeah, that checks, right? And then this one's weird. 3 times 1/9. Was it positive 1/9 or negative 1/9? Positive. Fantastic. The square root of 1/9? Oh, that's gross. Okay. And when I multiply this out, I get 1/3. And I'm going to go ahead and write this as 3/3 because it looks like I'm going to have a bunch of common denominators, right? Oh, sorry. When I take the square root of 1/9, I get 1/3. So that's 2 times 1/3. Is 1/3 equal to 3/3 plus 2/3? No way, right? No. That would say 1/3 is the same thing as 5/3. It doesn't check. So we go back down, and I'm going to say this one, good. This one, no good. It's extraneous. They're a hoot and a holler, aren't they? Here we go. Maybe you could say they are hoot and holler. I don't know. I like if you say the words hoot and the holler. All right, so let's do another one. Again, I need to get that by itself, right? That's my goal. So the first thing that I'll do then is I'll add x to both sides. And we're going to totally run out of room, but it's going to be okay. So that means I'll have 3 plus x on my left-hand side. And on the right-hand side, I'll have 4 divided by the square root of x. We'll divide both sides by 4. Those will cancel out. And I wind up with 3 plus x divided by 4 equals the square root of x. Now you need to square both sides. And when I square that, I'll have 3 plus x divided by 4 squared equals x. And this is where things get super fun, right? I'm going to go ahead and rewrite it up here. And I'm going to actually write that, right? 3 plus x over 4 squared is 3 plus x quantity divided by 4 times itself equals x. Now, be careful. Remember, in the last one, I showed you that you can multiply 3 by 4 and get that denominator to go away. Don't do it yet. You have to actually FOIL this thing out before you do that. Okay, so let's go ahead and get that foiling done. Except for, in order to do that, I really would like to rewrite this as 3/4 plus 1/4 1/4 x, right? X over 1/4 is the same thing as 1/4 x. Do you see how that's the same? I have this x over 4 right here, and I can actually pull that out. Because remember, if I was to multiply the x times the 1, I would get the x over 4. You know what I mean? So I can pull it out and write it as 1/4 x instead of writing it as x over 4. It's just nicer. Now let's FOIL. 3/4 times 3/4 is 9/16. 3/4 times 1/4 x is going to be 3/16 x. 1/4 times, so the 1/4 times the 3/4, or 1/4 x, my bad, times 3/4 is going to be equal to positive 3/16, right? I'm multiplying my numerators. I'm multiplying my denominators, x. And lastly, I'll do that one, right? Which is going to be 1/4 x times 1/4 x, which will be 1/16, and then x times x is x squared. Equal sign? We could combine like terms now, or we can just go ahead and multiply through by 16 before we combine like terms. It's up to us. Once we've FOILed it, we're allowed to do that trick. So let's just do it, right? As soon as we're allowed to, we can do it. So I am multiplying everything times 16. I'm really sorry for how crowded it is there. So that's going to give me 9 plus 3x plus 3x plus x squared equals x. Okay, I'm going to do my next step down below all this stuff. Sorry. Okay. So now I'm going to combine like terms. 3x plus 3x is 6x plus x squared equals x. We're almost there. Subtract x from both sides. And I'm actually going to reorder this and write this as x squared plus 5x plus 9 equals 0. Yes. Oh, thanks. Sorry. You're right. You're the man. All right. So I should be subtracting 16x from both sides. It's going to be a much better problem that way, too. All right. So I'll rewrite this as x squared minus 10x plus 9 equals 0. It turns out that it should be factorable, right? But yeah. Negative 9 and negative 1. That keeps coming up. It's interesting. So I can factor this. Negative 9 and negative 1, right? Those two multiply to get this positive 9, and they add to get the negative 10. So x is equal to 9, or x is equal to 1 are our possible solutions. But again, we need to check them. Oh my gosh, it's way up there. All right. 3 equals 4 root x minus 1. All right. So 3 equals 4 root x minus x. Okay, so let's check 9. So 4 times 3 minus 9. Yeah, that checks, right? 12 minus 9? Check. All right, let's try 1. 3 equals 4 times the square root of 1 minus 1. Yeah. Right? That's 4 minus 1. So they both check. Boom. So it's not always the case that that you'll have an extraneous solution. Sometimes they'll both work. All right, let's do this one. So my radical is already isolated, right? So I can go ahead and square both sides immediately. When I square x plus 5, the square root of x plus 5, rather, I just get the square root to go away. And then this becomes x minus 1 squared. Don't forget, right? We need to square everything on that right side and put it in parentheses. So it's going to be everything on that right side times itself. So I need to go ahead and FOIL this out. I'll just expand it first. And then we're going to FOIL it. It's going to be x squared minus 2x plus 1. Kind of skip that in between step where I combine like terms. Now I'm going to subtract x from both sides, and I'm going to also subtract 5 from both sides so that I can get 0 here. When I subtract x here, I get negative 3x, and when I subtract 5 there, I get negative 4. Turns out that this thing is factorable. I'm going to write it in its factored form right here. It's going to be x. What? Is it factorable? Negative 4 and positive 4. Sorry. So x equals 4 and x equals negative 1. That was much better than the previous one. Because we did not have those weird fraction things to deal with, right? So much better like that. Let's check it though. So is it true that 4 plus 5, I'm checking the answer, x equals 4, is equal to the square root of 4 plus 5, rather, is equal to 4 minus 1? Yes, right? Because 3 equals 3. All right, let's check x equals 1, so that one checks. So is it the case that the square root of 1 plus 5 is equal to 1 minus 1? No. No. So, oh, it should be negative 1. My bad. That's why. Negative 1 minus negative 1. Sorry. That comes to the square root of 4 equal to negative 2. It still doesn't check, right? Because the square root of 4 is all right then. So then our only correct answer is this one. All right. All right. So let's look at number 4. I need to isolate the radical, right? So a weird thing about that is that I have 2 radicals. Yeah. So my plan is going to be to subtract all of this stuff. All right, so I am going to go ahead and subtract this from both sides. Sorry, it's 2 square root x minus 8. So then I get the square root of 3x plus 7 equals negative 2 square root x minus 8. And now I need that negative 2 to go away. So I'll divide both sides by negative 2. Those are going to cancel. So I wind up with the square root of 3x plus 7, all divided by negative 2, equals the square root of x minus 8. Now I have radicals on both sides. It's time to square both sides. Yep. Yes, it is. I'm going to go ahead and write that next step up over here. So that's going to be the square root of 3x plus 7 times, divided by negative 2 squared equals, and when I square that square root of x minus 8, I just get x minus 8. Yeah?
Wait, what are...
What are those? I don't know. I'm just going to write the expansion of that. Now let's multiply, okay? So look, because this square root of 3x plus 7, because it's underneath that radical, it's locked in there. You treat it just as like one quantity, right? So when I FOIL it, I can't multiply the square root of 3x times the square root of 3x, right? I've got to do the whole thing. So I'm going to just write out what that looks like. So if I was to put this over one denominator, it'll look like this. And then we can multiply our denominators. That becomes 4. And you're going to see something really cool happens here, right? Remember at the end of lesson 28, we did multiply something like this, right? Something like what's our numerator? And it turns out that if I multiply the square root of 3x plus 7 times the square root of 3x plus 7, isn't that the same thing as the square root of 3x plus 7 squared? Yeah. Which means that our radical just goes away. It's awesome. So that's why I am able to go from there to there.
Oh, come on.
Okay, I'm going to go ahead and multiply both sides by 4. Put that in parentheses so we know I'm multiplying the whole thing. Those are going to cancel. And then I get 3x plus 7 is going to be equal to, I'm going to go ahead and distribute that 4 so that I get 4x. And then 4 times the negative 8 is going to give me negative 32. Now we have a simple linear equation. And I really like to get rid of my x's first, right? And we all know why. We don't even think. So I'm going to subtract 3x from both sides. I'm going to bring that up so I can reach it. We get 7 is equal to x minus 32. Now I have to add 32 to both sides. And that will give me 39 is equal to x. And that's fantastic. But hey, we need to check it, don't we? You sure do. You sure do. Okay, so let's check it. Let's go back. So we said x is 39. So we'll go back over here. I guess I'll plug it in. So somewhere over here, I'll just make a little spot. Here we go. This will work. So we'll go, no, that's not going to be enough room. Let's do it right here. So, 3 times 39 plus 7. So you said that was what? 117 plus?
Or 24. Yeah. 3 times 35 plus 7.
Okay, 124. We'll just go down to 1 first. Perfect. Thank you so much. Plus 2 times 39 minus 8 equals 0. And that's going to be 2 times the square root of 31. I don't know, put that in your calculator. Do you get 0? No? So darn, this thing has no solution. Yes, because, you're right, because that guy right there is extraneous. Okay. All right. All right, let's do another one. Okay. Again, I need to isolate at least one of these radicals. So I'm going to go ahead and subtract the square root of x from both sides. So that's going to give me, I'm going to write it over here because I have a feeling I'm going to run out of room. So that's going to give me the square root of x plus 3 is equal to 3 minus the square root. Minus the square root of x. And so now I need to square both sides. So when I square my left-hand side, it just takes my radical away, and I'm going to write the right-hand side like that, as that whole quantity squared. And we'll expand it. So that's 3 minus the square root of x times 3 minus the square root of x. And now we need to distribute or FOIL. So we get x plus 3 equals 3 times 3 is 9, and 3 times root x is negative 3 root x. Negative root x times 3 is negative 3 root x. And negative root x times negative root x is positive x, right? Let's go ahead and combine like terms. And now we need to isolate the radical again. So in other words, we need to get this guy by itself. So let's go ahead and move everything over to the right-hand side. Yeah, that'll work. Okay. So I'll subtract 9 from both sides, and go ahead and subtract x from both sides at the same time. And I can do that because all of my like terms have been combined. So let's just do like y. All right, so that's going to give me negative 6 equals straight up. Well, that's awesome that those x's canceled. That's really good. Oh, this got really nice. Oh, thank you. I love it when you do some algebra and you're like, thank you for going away everything that was driving me like crazy. Now I've got to divide both sides by 6, negative 6. I have a negative divided by negative, which is a positive. I'm going to just drop this down here. 1 equals the square root of x. So when I square both sides, I wind up with 1 squared equals x, or x equals 1. That's lovely. We are going to have to plug it back in. Okay, so now I need to go ahead and plug that back in and see if I get a true statement. So let's do it. Let's do it over here. So is it true that the square root of 1 plus the square root of 1 plus 3 is equal to 3? Well, that would be 1 plus the square root of 4, which is 1 plus 2. Yay, that's a real solution. All right, let's do another one. Hey, look at that. Okay, so again, I want to get at least one of these radicals by itself. So I'm going to go ahead and subtract the square root of x plus 5 from both sides. So that is going to give me the square root of x minus 3 is equal to 4 minus the square root of x plus 5. And now it's time to square both sides. And this is going to get funky. So that is 4 minus the square root of x plus 5 squared. And then when I expand that, that actually becomes 4 minus the square root of x plus 5 times 4 minus the square root of x plus 5. So now I gotta FOIL that. It's gonna be fun. Believe me. Alright, so 4 times 4 is 16. And now we gotta do 4 times negative square root x plus 5, which is gonna be negative 4 times the square root of x plus 5. So I'm just gonna write that 4 as a coefficient, right? I'm just gonna put it out in the front. I'm not gonna try to distribute it. I'm just gonna leave it out in the front, okay? Don't try to do this. Don't try to multiply the 4 like that. It's not good. It's not right. Don't even write it down. I'm erasing it right now. Okay? Don't do that. People do that. Remember, this is kind of locked in there, right? That radical kind of locks that x plus 5 in there. It can't be touched. So let's go ahead and multiply that. So it's going to be a negative 4 root x plus 5. And then the last thing is negative root x plus 5 times negative root x plus 5, which is going to be plus x plus 5, right? It's going to take the radical away, right? Because negative root x plus 5 times negative root x plus 5 is the same thing as negative root x plus 5 squared. And when I square my square root, it makes the square root go away. So just remember, square root times square root makes the square root go away. Alright. I'm going to write this up here, and I'm going to combine like terms at the same time. So everything on the left-hand side is good. Over here, I have a negative 4 root x plus 5 and a negative 4 root x plus 5, which gives me negative 8 root x plus 5. And then I have plus x plus 5. Alright? So now, my goal is to now isolate this radical. I'm going to get that one by itself. Now, one of the radicals go away. Now I got to work on getting the other one. So I'm going to go ahead and first get everything over onto the left-hand side. Well, let's combine my terms first. So I have this 16 and this 5 that can be combined. So I'm going to go ahead and combine those. That's 21. The third of 12. That's 21. 21. I can't even say that right anymore. Okay. So now I'm going to subtract 21 from both sides and subtract x from both sides. So that means this 3 is going to subtract 21, and my x is going to subtract x. I love that, because that means my x cancels. All I'm going to have over here is negative 24, and over on this side, negative 8 root x plus 5. It's getting better. Now I'm going to divide both sides by negative 8. Those cancel. And then I'll have 3, right? Because negative 24 divided by negative 8 is positive 3 equals root x plus 5. How am I going to get that radical to go away? I'm going to square both sides. Thank you. So that becomes 3 squared equals x plus 5, which means that 9 is equal to x plus 5. And when I subtract 5 from both sides, I get 4. Yes, they are a little long. It'll take a little while to get done. And we get to check it, which is the best part. 4 minus 3 plus the square root of 4 plus 5 equal to 4. Is that true? So is the square root of 1 plus the square root of 9 equal to 4? So that's a real answer in real life. Okay, are we ready to do another one? I am. Here we go, let's do this last one. Alright, again, oh look, my radical's already by itself. That's lovely. So that means that I can just automatically square both sides. Beautiful. I like that. So this becomes 3 plus square root x times 3 plus square root x equals x plus 81. I'll FOIL this out. 3 times 3 is 9. 3 times the square root of x is 3 square root x. Square root x times 3 is also 3 square root x. And square root x times square root x, remember those? That square root goes away. Boom. Alright. Time to combine like terms. 9 plus 6 root x plus x equals x plus 81. And now I would like to subtract x from both sides and subtract 9 from both sides. Now that my like terms are combined, right? I can do that. So my 9's cancel over here. All I have left on my left-hand side is going to be 6 times the square root of x. And all that I have left over here on this side is going to be 70. I'll divide both sides by 6. Those cancel. 6 goes into 72 12 times. So I need to square both sides. And 12 squared is 44. Fantastic. Alright, thanks for watching. I know you really enjoy doing these things, so I'm glad I could provide you with a rich source of entertainment. Bye.